This is population ecology. First, we start out with population ecology. We start out with the size of a population, which is represented by N. Leaving the population, we have immigration and deaths. Adding to the population, we have immigrations and births. All of this factors into intrinsic growth rate, which is represented by R. This means, is the population increasing or decreasing? Next, we have the equation to find intrinsic growth rate. So we have a change in N, represented by births minus deaths, and immigration minus emigration. We're going to show this with a population of rabbits. We have a population of 5 rabbits, N naught equals a first population. This rabbit is going to have 2 baby rabbits. Births equals 2. 1 rabbit is going to die. 1 rabbit is going to join the population or immigrate, and 2 rabbits are going to emigrate out of the population. Now we can find our change in N. So we have births minus deaths and immigration minus emigration, which represents an added calculation equals 0. To find the intrinsic growth rate, R, we have to do R minus, which is the change in population over the initial population. So R equals 0, or nothing. Now we're going to see a larger population, slightly larger, in starfish, which our Little Mermaid is going to watch over them carefully. So this starfish population is represented by initial population of 11. 2 starfish are going to give birth, and 1 starfish is going to join. So our birth is going to be equal 5, our immigration equals 1. 2 starfish are going to die, and none are going to emigrate because this is an awesome place to live. Now we're going to calculate and add that into our equation. So our change in N is actually going to equal 4. To get the intrinsic growth rate, I need to calculate, and that is going to equal 0.36. So it's an increase. That is a growing population. Other factors that we can look at in a population is density. So we can have a population of 5 in a small area or a large area. We can look at distribution, which can be represented with these smiley faces, which is uniformly or completely random. The next one we're going to see is age structure, which we can have 2 females and 1 male or all females. Problem with this? Yes, they will not grow if they are all female. Sex ratio. Wait. Sex ratio is what I talked about just above. Whoops. We'll do age structure again, 2.0. Now age structure can be represented, we can look at the age of the population, whether the population is uniform, growing. So we have 1 adult rabbit, have 2 little rabbits, and we have 1 grandpa rabbit, and that is the age structure of this population. But there are factors that affect intrinsic growth rate, so how a population increases or decreases. One is density dependent, which means that this is limiting resources in the area that the population is living in, or the increase of disease when the population increases, and this represents K, which is carrying capacity of the population. The next one is density independent, which is completely random, of chance, so the population can be affected by a fire or a tornado, like that famous movie Sharknado. Now, these populations can be represented in models. So the first model we're going to look at is exponential model, which is R, which is intrinsic growth rate, which is what we've been finding. This is simply just a J-shaped curve where the population has no ending and is constantly growing. Then we have our logistic model, which is our K, our carrying capacity, which we talked about, which is the population is going to increase at first, but then it's going to reach carrying capacity and level off because the area it's in cannot withhold their size. But it will not just level off, the population will have dips and curves around carrying capacity. To summarize what we have just learned, we have population, which is the initial size of the population. We have emigration and deaths, which take away from the population. And we have immigration and births, which add to the population. All of this is adding to the intrinsic growth rate, so how the population is increasing and decreasing, and at what rate it is increasing and decreasing. Next, we have the additional factors we can look at the population. We have our density, our distribution, our age structure, and our sex ratios. Next, we have our factors that affect intrinsic growth rate. We have our density dependent, which is our carrying capacity. And then we have our density independent, which is our chance encounters like fires, floods, natural disasters, etc. Then we have our lovely equations that we can use to calculate basic change in population and the increase-decrease rate of the population. Thanks for watching my video on population.